Hello everyone, welcome back to my channel Study with me. Today I'm going to explain about Chemistry Higher Level Paper 1 May 2023 Time Zone 2. If you find this video is helpful, don't forget to subscribe and let's get started. Okay, what is the mass of one molecule of C60? To find the mass, the formula will be number of atoms C times mR of C and divided by Na. That would be 60 times 12.01 divided by 6.0 times 10 to the power 23, which is 1.2 times 10 to the power negative 21 gram. So the answer will be D. Number 2, 20 centimeter cube of gas A reacts with 20 centimeter cube of gas B. So 20 centimeter cube gas A reacts with 20 centimeter cube gas B, produce 10 centimeter cube gas AXBY, and there is excess 10 centimeter cube gas A. So based on this, we can see that 20 centimeter cube gas B reacts completely or used up all, but only half of gas A reacted. So every 20 centimeter cube of gas B produced 10 centimeter cube of gas AXBY. Therefore, twice for gas B and half for gas A. So we can say this is 2 moles and this is 1 mole. So the formula will be A1, B2. So the answer is D. The volume V for a fixed mass of an ideal gas was measured at constant temperature at different pressure, which graph shows the correct relationship between PV against P. So if T is constant, it's a Boyle's law. But different pressure, so P is directly proportional, is inverse. P of a gas is inversely proportional with V, or K per V. Okay, so PV is constant. All right, so when pressure increases, V decreases to keep PV constant, or if volume increases proportionally to maintain PV. Therefore, the correct graph, PV is indeed a straight line when pressure increases. What is the correct ground state electron orbital configuration for 2s2 2p2? 2s2 2p2, Pauli's rule, each orbital can hold a maximum of 2 electrons. So in this case 2s, but not the same direction like this. And we have A and B, but the electron spin is pointing up first and then pointing it down. So we need to pointing it up all and then pointing it down. So this is incorrect. Therefore, the answer is A. The successive ionization energies for an element in period 3 are shown. So we have Na, Mg, Al, and Si. So for Na, the electron number is 211, so 281, and Mg 282, Al 283, and for Si 284. Okay, so higher jump to remove the 4th electron, and 3 electrons are easier to be removed, so definitely not 1. So because the second electron is easier to move, and 2 also no, but C, 3 electrons are easier to be removed, and the fourth one, because it's coming from the second shell, so higher jump of ionization energy, but 4, so the third and fourth ionization energy should be closer. That's why the answer will be C. Which sequence has the oxides arranged in order of increasing acidity? Okay, so it will start with alkaline in the periodic table, and then we move to amphoteric, and then we move to acid. This is non-metal, and this is metal. So it will start with increasing acidity, so non-metal should be the last. So non-metal is S, and metal should be the beginning, which is Na. That's why the answer is A. Which properties increase down the group 1 alkaline metal? Increase number of electron will increase number of shells, and the atomic radius also will be increased, so the first one is correct. And because number of electron increases, number of shells increases, the radius will be increases, so the electron will be less tightly held by nucleus, and melting point will decrease. So radius will increase as well, and then melting point will decrease. So reactivity with water will decrease down the group, because more reactive to react with water, for the reactivity with water also will increase, because when you go down, the reactivity will increase. So therefore, the answer will be atomic radius and the reactivity with water. Which of these factors explains why NiCl4 and COCl4 have different color? Okay, if we see the oxidation number, this will be -4, this will be -4, and because it's 2-, so this will be +2, and this will be +2. So the oxidation number are the same, the charge on the metal are the same, and then they have also the same ligand. And for the configuration electron, if we do Ni with number 28, so that will be Ar 3D8 for S2, and for CO that would be 27, would be Ar 3D7 for S2. So different electronic configuration will have different absorption spectra, so the identity of the metal ion itself are different because it will give different color. Which compound has an element with an incomplete octet of electrons? So BF3, because in BF3 we have only 6 electrons, so it is incomplete. If it's CF4, as you can calculate this 1, 2, 3, 4, 5, 6, 7, 8, O F2, also 1, 2, 3, 4, 5, 6, 7, 8, and then Cl F3, that would be also 1, 2, 3, 4, 5, 6, 7, 8. Okay. What is the correct sequence if the compounds are arranged in order of increasing boiling point? So we have here the methyl ether, and then we have ethanol, And then we have ethanol. Okay, so ethanol definitely will be the highest one because it has hydrogen bonding. But for ether, because symmetrical arrangement around oxygen atom causes dipole moment cancellation, so the boiling point will be the smallest one. And for ethanol has it's more polar compared to ether, because ether has a dipole moment cancellation. So it will start with dimethyl ether and increase to ethanol and increase to ethanol. What is the correct comparison of H and H bond angles in NH2 minus, NH3, and NH4 plus? So NH2, if we draw the Lewis structure, and then NH3, and then NH4 plus. So the bond angle, this is very small than 109, and this one small than 109 degrees, and this one is 109, tetrahedral, trigonal pyramid, and bent. So the answer will be A. Which is the valid and preferred Lewis structure of the NO2 radical based on formal charge? This definitely no, because it should include single and double bond. And NO2 radical should consist one nitrogen atom with one single electron, which is in this case A or C, and also can participate in resonance. So this one cannot participate in resonance. So the answer will be C. Which wavelength and energy of light will break bonds in ozone rather than oxygen molecule? So for ozone, and oxygen, ozone experience delocalized electron, so it's not very stable as oxygen that has stronger bond. And because ozone experience delocalized electron and is weaker, therefore the longer wavelength and lower energy compared to oxygen. The enthalpy of formation of ammonia gas is negative 46 kilojoule per mole. What is the energy release in kilojoule in the reaction? As a free element, so delta HF, it's 0. So this will be negative 46. So if we do the calculation, will be 2 times negative 46 because it's 2. So that would be 92. Why it is negative? Because release the energy. Okay, when 100 centimeter cube of 1 mole decimeter cube HCl is mixed with 100 centimeter cube of 1 mole NaOH, the temperature of the resulting solution increased by 5. But what will be the temperature change if we have the volume but we double the concentration? The IB mass scheme is 10, but when I do the calculation, I feel like the answer is 5 because look, for the first scenario, the volume of HCl is 0.1 decimeter cube, and the concentration of HCl is 1 molar. Okay, and for react with NaOH, so volume of NaOH is the same, which is 0.1 decimeter cube, and the concentration of NaOH, it's also 1 molar. So this will give you 0.1 mole, and this will give you 0.1 mole as well. And for the second scenario, okay, so volume of HCl, it's 0.05 decimeter cube, and the concentration of HCl is 2 molar, and volume of NaOH is the same, which is 0.05 decimeter cube, and volume of NaOH is 2 molar. So if you do the calculation, this one also will give you 0.1 mole, and this one will also give you 0.1 mole. The temperature difference here is 5 degrees Celsius, because the mole are the same, there is nothing changed, only increase the concentration. So delta T will be 5 degrees Celsius as well, but maybe because of the concentration are more, so it will produce more free ions compared to the first scenario. So that's why maybe the Mars scheme is 10, so double the concentration, so the temperature difference also will be double, which is 10. Okay, which of these changes involve an increase in entropy? Okay, so let me make it a little bit bigger so I can write here. So for the A, doesn't change number of moles, it's just adding the electron. So for B as well, you can see solid to gas. So from solid to gas, obviously the entropy will increase, but from gas to solid, the entropy will decrease. So B is not. And for C is from 1, the coefficient from 1 to half, even though gas to gas, but the coefficient decrease, so the entropy will decrease. And for this solid to gas, the entropy will increase, and this one, not both of them increases. And this one, from the smaller coefficient to bigger coefficient, half to 1, so the entropy will increase. And solid to gas, the entropy also will increase. So the answer is D. Which is correct when delta H minus T delta is 0? It's in equilibrium condition, because when the equilibrium condition delta G will be 0, it means the reaction occurs at equilibrium. If it's negative, it will be forward reaction forming more product. If its delta G is positive, it will be reverse reaction forming more reactants. So the answer will be C. Number 18. Curve X on the following graph shows the volume of oxygen formed during the catalytic decomposition of a 1 molar solution of hydrogen peroxide. As you can see on this graph, volume in Y is more than X, and it's faster. The time is faster compared to X curve. So which change would produce the curve Y? Adding water will not affect the rate of reaction because water is not involved in the reaction. There's no water. Adding 0.1 molar hydrogen peroxide would increase the concentration of reactant, okay, because the reactant of the concentration of reactant increases, so the rate of reaction will increase, so the volume of volume oxygen in Y graph will also increase. So we keep it for B is correct. But what about C? Adding 2 molar H2O2 would significantly increase the concentration. Therefore, it will be so fast, the reaction will be very fast, and the volume of oxygen will be also higher. But in this case, it's not that very high. And repeating the experiment without a catalyst will decrease the rate of reaction. So the volume of oxygen will reduce. So B is the answer. Which two colliding species have the highest probability of having the proper orientation for a reaction to occur? For the first one, Cl radical and Cl radical, it involves two chlorine radicals forming Cl2. The orientation is very, indeed, critical. For B, Cl2 radical and CH3 radical, even though it involves a chlorine radical colliding with the methyl radical, but the methyl radical's radius size is a bit more challenging for them to have a proper orientation. And for C, involves HCl reacting with ethylene with its larger structure, make it even more difficult. And for D, involves 3-fluoromethyl chloride reacting with ozone. Both molecules are very complex, which make it even more difficult compared to a simpler molecule. So that's why the answer will be A. Okay, which proposed mechanisms for the following reaction is consistent with the rate of law? We've got 4 of this option, so the fast step will not be included because it's not a rate determining step. So we need to get this rate, which one is suitable based on this 4 option. So the first one rate will be K, so NO times F2, and then the B will be F and NO. It's based on the reactant, okay, reactants. And then for C will be NO to the power 2 and then F2. And for D will be NO to the power 2. Okay, so the answer will be A because NO and F2. Okay, for number 21, which value increases when the temperature of reaction increases is rate constant, because K as a rate constant is dependent on temperature. As temperature increases, so does K. As temperature decreases, so does K as well. So it's a rate constant. Which condition will cause the given equilibrium to shift to the right? For A option, it will disturb the equilibrium. And for B, when water is added, will not affect equilibrium since water is a solvent, so it doesn't participate in the reaction. And when solid and ACl is added, will cause an increase in solid silver chloride because adding solid and ACl will add chloride ions as well. So the increase in Cl minus concentration will cause equilibrium shift towards the right. And for D, the system is subjected to increased pressure. There is no gas molecule, so it doesn't give any effect. Number 23, which values of equilibrium constant K and Gibbs free energy delta G favor the reverse reaction of an equilibrium? So if the equation is delta G negative RT ln K, so if K smaller than 1, ln K is negative, so delta G will be positive. If it's K bigger than 1, so ln K will be positive and then delta G will be negative. So therefore the value of K is smaller than 1 will give delta G positive. Number 24. What is the order of increasing conductivity for aqueous solutions of these acids and bases at equal concentration? If pKb smaller, it will give a stronger base. So we can give this ethanol is the weakest one, and then phenylalanine, and then methylamine. Okay, so when it comes to the conductivity, it is more about the amount of free moving ions, or the amount of ions. So the stronger will dissociate more, so it will have more ions, so it will have higher conductivity. And methylamine is the strongest one. Therefore, we can give the order start from the ethanol and then moving to phenylamine and then moving to methylamine as the strongest one. Okay, which graph represents the pH curve of a weak base titrated with a strong acid? So this one is strong base and this strong acid, and this one weak base and strong acid, and this one strong base and weak acid, and this one definitely weak base and weak acid. So the answer will be B. Which condition results in a buffer solution? When making buffer solution, it always contains an acid and base, and there are two types of buffer. Acid buffer, it contains weak acid, and alkali buffer should contain weak base. So if it's weak acid and strong base, this will produce acid buffer, because partial neutralization, it means it's a weak acid, and these are the pair to make acid buffer. Okay, so the ionic product constant of water is 3 times 10 to the power negative 15 at 10 degrees Celsius and 5 times 10 to the power negative 15 at 98 degrees Celsius. What is the true about the hydrogen and hydroxide ion concentration when pH 7? We will do a little bit of calculation here, so I need more space. So let's do the first scenario, which water constant, it's 3 times 10 to the power negative 15. This is OH minus and then H plus. So the pH, it's 7. Therefore, let's plot into this formula. So it's 3 times 10 to the power negative 15, and concentration of H plus is 10 to the power negative 7 because pH is 7. Okay, so OH minus will be 3 times 10 to the power negative 8. And for the second scenario, the number is 5 times 10 to the power negative 13. So to find the concentration of OH minus, okay, we just plot into this number again. So pH is 7, so this will be 10 to the power negative 7. So OH will be 5 times 10 to the power negative 6. So if we compare these two, okay, so looking at this number, the concentration of H plus is bigger than OH minus, and for this scenario, 98 degrees Celsius, concentration of H plus is smaller than OH minus. Therefore, the answer for the question number 27 is D. Which species is the oxidizing agent? If it's oxidizing agent, it will experience reduction. Okay, so Mn, 2Mn plus 2, and this will be -1 equal to -1. So O3, O is -2 times 3, so -6. So Bi will be plus 5, and this will equal to -1. So O8, O4, -8, because -2 times 4. So this will be plus 7, and this will be plus 3. So Bi plus 5, 2 plus 3, reduce the number. So it's reduction, therefore is oxidizing agent. Which chemical process would produce a voltaic cell? So the SHE, number 29, which chemical process would produce a voltaic cell? Voltaic cell operated based on the spontaneous redox, converting electrical energy through transfer electron from the reducing agent to the oxidizing agent. This flow of electron generates an electric current, thus it is spontaneous. Which combination of potential or voltage is correct regarding the reduction and oxidation of this standard hydrogen electrode? The SHE, or standard hydrogen electrode, is assigned an electrode potential of 0.00 voltage with the standard electrode potential of other half cell. So reduction potential will be 0, and oxidation potential also will be 0, which will eventually yield the greatest mass of deposit copper in the electrolysis of a fixed volume of 1 mole decimeter cube CuSO4. That will be copper anode and inner cathode. But why not deposit at the cathode? Because the other electrode is inert. Okay, so when it's inert, the mass doesn't change. Inert is a material that doesn't react during electrolysis. It only provides surface for ions to be reduced without undergoing any chemical changes itself. Inert electrode doesn't change the mass. So why it is at the anode, the greater mass of deposited copper more at the anode while not at the cathode? You know, the copper ion in the solution migrate towards the cathode. Since the cathode is inert, it doesn't participate in the reaction, but serve as surface for the reaction to occur. So during electrolysis, some ions are also discharged at the anode, leading formation of sulfate ions, then react with the copper anode, causing it to dissolve and release copper ions. As the inert cathode doesn't participate, the greater mass of deposit copper that's supposed to be at the cathode is redeposited back into the solution due to reaction occurring at the anode, leading to a higher concentration of copper ions near the anode. Which compound is an aromatic ester? ester is RCOOR. So the answer is B. Which reaction mechanism involves heterotic fission of chlorine? Heterotic fission of chlorine is breaking the bond in the chlorine molecule, so that one chlorine gains both electrons from the bond forming Cl- ion and Cl plus ion. For the first one, electrophilic addition, Cl2 splits into Cl- and Cl+, reacting with alkenes because it's addition. Cl2 will be added to the alkene, double bond of in the alkene. And for the second one, electrophilic substitution, Cl2 undergoes heterolytic fission to form Cl- and Cl+, allowing Cl+ to replace hydrogen atom. And for the third one, Cl2 breaks into Cl+ and Cl-, enabling nucleophile to replace Cl-. Therefore, three of this addition, substitution, electrophilic addition, electrophilic substitution, and nucleophilic substitution involve heterolytic fission of chlorine. What is the preferred IUPAC name of the structure shown? So if you're confused with this structure, I will write it down more clear. So CH3, so it will be C and CH3, and this will be C, this will be OH, and this will be CH3, and this will be CH3, and there is one H right here. So we will start from 1, 2, 3, 4. So it will be 2 all. So the alkyl will be at 2 and 3. So 2.3 dimethyl butane 2 all. What is the correct order reaction types in the following sequence? So CH3H7Br and C3H7OH, there is nothing is added, only OH. Br is replaced by OH, so this definitely substitution. So it's between A and D. So now from C3H7OH, this is primary alcohol. So you know, when you oxidize primary alcohol, it will produce aldehyde first, and then you oxidize one more again, so it will produce carboxylic acid. So this is oxidation, okay, and this is aldehyde, as I said. So from primary alcohol, if you do oxidation, it will produce aldehyde, and then if you do again oxidation, it will produce carboxylic, okay, acid. So this oxidation. And if you do reduction, so this will be the other way around. So if carboxylic acid is reduced or experience reduction, it will produce aldehyde. So this will be reduction. That's why the answer it's A. The observed specific optical rotation of a compound is +7. What is the specific optical rotation of a racemate of this compound? The specific optical rotation of a racemate is a mixture of equal amounts of enantiomer. It's always 0. This is because the rotation of the two enantiomers cancel each other out due to their opposite direction of rotation. Therefore, the answer will be 0. Number 37, which mechanism does the nitration of benzene proceed by? So it's an O2 plus, which is electrophilic and is substituting one of the hydrogen atom. So electrophilic substitution. Which observation would explain a systematic error for an experiment involving the combustion of magnesium to find the empirical formula of its oxide? It's definitely the crucible had black soot on the bottom after heating. A systematic error occurs due to a flaw in the experimental setup or procedure. The presence of black soot on the bottom of the crucible after heating indicates incomplete combustion, which would lead to inaccurate results in determining the empirical formula of the magnesium oxide. Which technique is best for determining bond length within a molecule? So, X-ray crystallography, because X-ray crystallography is a precise technique for determining bond length within a molecule. NMR is used to determine molecular structure of organic compound, infrared spectroscopy for functional group in the molecule, mass spectroscopy to identify of molecular weight. Okay, for number 40, the following graph showed the concentration of C4H9Cl versus time. So you need to find the average rate. So if you draw the line, you will find that delta y will be 0.08 minus 0, and for delta x will be 800 minus 0. So if you divide delta y divided by delta x, you will get 1 times 10 to the power negative 4. So the answer is B. All right, so that's it for the Time Zone 2, Paper 1, Chemistry, 2023, May. No, so if you find this video helpful for you for the exam preparation or revision, don't forget to subscribe. Thank you for watching, and bye for now.